A groundbreaking study has just unveiled a disturbing find about the interstellar wanderer known as 3E Atlas. Right at 2.1 astronomical units away from the Sun, 3E Atlas began releasing hydrogen cyanide, a stealthy, lethal vapor. Experts refer to this as outgassing. But what they're keeping quiet about is this. Comets don't simply pause their activity and then spew toxins at a set point. Still, that's precisely what Atlas pulled off. During this event, NASA's primary asteroid tracking spacecraft fell silent, with vital info from its nearest pass vanishing from official logs. Just a fluke or something sinister? This evening, we're uncovering the secrets behind that silence. Stick around through the whole thing, since the concealment wraps up right here. If these enigmas grab you like they do me, smash that like button and sign up for updates. You won't want to skip the follow-up twists. As the tale unfolds further, drop a comment below. Where in the world are you tuning in from? What's the hour like there? And do you believe we're getting the full scoop on these revelations, or merely the sanitized tale they prefer? To amp up the buzz, pass this clip along on X, Facebook, Reddit, or your personal message threads. You're the powerhouse fueling our quest for answers. Thanks for joining the fight. Part 1. The Toxic Trigger. Envision yourself as an astronomer peering into the evening heavens, monitoring what seems like yet another frozen fragment of cosmic debris from outside our system. Then, one dawn, incoming readings freeze you in place. The entity you've been observing, the one gliding quietly across the cosmos for ages, has abruptly started spewing a plume of hydrogen cyanide molecules into the emptiness. No slow buildup, no expected progression, but an instant surge, as if a lever got pulled. This isn't guesswork, it's verified research. The James Clerk Maxwell Telescope picked up hydrogen cyanide signals from 3E Atlas on September 14, 2025, when it sat 2.13 astronomical units from the Sun. The signal hit over 5 sigma certainty, so the odds of it being bogus are slimmer than 1 in a million. Output clocked in at 0 plus or minus 1. 7 times 10 to the 25th molecules each second. No error there. We're discussing trillions and trillions of cyanide particles pouring out nonstop. Before you peg me as an alarmist, let me break down hydrogen cyanide for you. Chances are you've come across it. It's the stuff behind the sharp almond scent in some pits. The toxin deployed in grim episodes of chemical combat throughout history. Inside you, it halts cell breathing right at the core. You essentially choke internally, even with clear airways. Yet, the key point, hydrogen cyanide shows up naturally in comets. Plenty harbor it, trapped in frozen cores, trickling out steadily as heat builds en route to the Sun. Spotting it isn't inherently shocking. The shock comes from the timing and the manner. Examine the sequence. In August 2025, with 3 Atlas farther out and chillier, expected to be quieter, stargazers kept tabs on it. The James Clerk Maxwell Telescope aimed its array at Atlas several times that month. They hunted for hydrogen cyanide traces at those precise wavelengths, identical techniques, and turned up zilch. Zero hint, zero trace. The readings stayed blank, barren, mute. Fast forward to mid-September. Atlas edges in a bit, hitting 2.1 astronomical units. The scope checks once more, same protocol. Boom! The hydrogen cyanide trace erupts into view. No creeping rise, no gentle thaw effect, just a sharp onset. Ponder the implications. It's like eyeing a sleeping mountain. For ages, it's still and cool. Sensors pick up no heat spikes, no fumes, no shakes. Then, out of nowhere, sans the classic cues of molten shifts or earth tremors, it blows its top. You'd puzzle over the catalyst, right? You'd figure some odd force stirred below, an unknown process. That's our spot with Atlas. Standard comets ramp up gas releases bit by bit with stronger sunlight. H2O mist leads, followed by CO, then assorted ices in a logical lineup based on melt points. Atlas blew past that pattern. It jumped from total shutdown to pumping out one of chemistry's nastiest substances, and at a range where most space rocks are just stirring. Here's a wild idea that clicks once you mull it over. Suppose 3 Atlas isn't some inert frosty relic tumbling haphazardly through the stars. Imagine it's a hibernating device, crafted by an intelligence to spark alive at a targeted solar range? What if that hydrogen cyanide burst isn't haphazard ice melt, but is it a deliberate blackout, Or maybe the telltale exhaust plume from onboard systems firing up. I get how wild that might come across. The knee-jerk response is to brush it off as paranoid speculation. But hear me out. Over the coming hour, I'll guide you through a chain of incidents, oddities, and apparent concealments that, pieced together, form a narrative way more eerie and unsettling than your average comet flyby. We'll scrutinize the reasons behind NASA's Psyche probe suddenly losing contact right in the prime time frame for snapping top-notch shots of Atlas. We'll probe the puzzle of its disappearing tail, where Atlas sported an anti-tail aimed straight at the sun, bucking fundamental physics. We'll uncover why the European Space Agency is holding back spectral readings from their Mars satellites, doling out just fuzzy snapshots while insisting they require months to sift through data that ought to be a breeze to interpret. And we'll stack Atlas up against a typical comet, like Comet Swan, to highlight precisely how outlandish Atlas really appears. When we're done, you'll see why a few investigators are whispering inquiries that the broader scientific community shies away from voicing openly. Inquiries into man-made artifacts, concealed motives, and whether we're gradually being conditioned for a disclosure we're ill-equipped to handle. But to start, we have to grasp the events of that quiet stretch. While Atlas was unleashing its toxic haze, peculiar developments were unfolding with our probes. Developments hinting that certain parties prefer we not peer too intently at this thing. And that's the real starting point of our probe. Part 2, the quiet stretch. Psyche falls silent. NASA's Psyche probe blasted off in October 2023, tasked with what seems like a basic objective. Head to the metal-packed asteroid Psyche, which circles between Mars and Jupiter, and probe its makeup to gain insights into planetary hearts. It's basically a resource scout, outfitted with tools for multispectrum imaging, magnetic field detection, and gamma-ray analysis. Yet here's why Psyche ties into our tale. Its path and gear allow it to spot other items in the inner solar system. It's not built for chasing rocks or icy wanderers, but if a noteworthy target drifts into its sight line amid the journey phase, Psyche can surely snag it. And come early September 2025, a truly noteworthy item was set to enter its view. 3E Atlas hit its nearest pass to Psyche's spot around September 3rd and 4th. The setup was almost ideal. Atlas was luminous enough, near enough, and angled so Psyche's cameras could grab sharp details, possibly picking out surface details or dusty envelopes that Earth telescopes couldn't resolve. This was the golden opportunity. This was prime time for the sharpest spacecraft angles on Atlas. Yet that's not what happened. We got radio silence instead. The Psyche project keeps an open data repository where refined photos get posted on a steady basis. Experts, reporters, and astronomy buffs can sift through the logs, following the craft's path and its routine tech trials. If you dig into that repository methodically, checking the dates on the photo records, a strange pattern emerges. A void. From September 1st to September 7th, 2025, the records list 0 images. Zilch. No log sightings, no setup shots, no tech trial frames, nada. The craft basically vanished from view for 7 straight days, perfectly enclosing the interval when Atlas was nearest. Now, before you leap to wild theories, I'll cover the everyday rationales. Probes aren't always active. They build in pauses for gear recalibrations, code updates, or signal handoffs when the deep space antennas shift focus. Occasionally, a glitch in the computer's triggers safe mode, powering down extras until mission crews troubleshoot. From time to time, info lags in refinement, so snaps from a given window might not hit the public feed for weeks, pending tweaks and reviews. All standard stuff in orbital work. But the issue here? NASA hasn't addressed the void. No press release notes a routine gear tweak in that slot, or a signal snag with early September info still in the queue. Just crickets on the quiet. I followed up via open avenues. I scanned project logs. I scoured NASA's outward messaging. Zip on this exact hole. It's like the whole Psyche crew separately chose, all at once, that the opening week of September didn't merit records, or that logging it was too dicey for open sharing. Ponder what that suggests. If the void is genuinely, it's downright coincidental that Psyche's routine upkeep happened right when Atlas swung by at its nearest point, and you'd think there'd be full disclosure. You'd figure NASA would come clean. Yep, we were down during that time. This is the reason. Regrettably, We skipped spotting Atlas, but check out our backup plans. The total lack of any rationale points to either gross carelessness verging on utter bungling or a purposeful holdback of findings that NASA isn't keen on sharing just yet. Let's scrutinize the schedule a bit closer. Atlas kicks off its hydrogen cyanide releases on September 14th, only 10 days following this odd downtime stretch. In that downtime slot, Atlas was near enough for sharp spacecraft photos. Once the downtime wraps up, Atlas pulls back and starts its chemical shift. It feels suspiciously like somebody aimed to block any crisp shots from the key shift phase. The moments when Atlas could have been altering, sparking to life, displaying outward hints of its upcoming gas surge. If Atlas turns out to be man-made, with detectable frames or vents or devices that give away its origins, such traits might only show up under intense, probe-level scrutiny at close range. Even top-ground telescopes render Atlas as barely more than a blurry speck. Psyche had the potential to flip that script, yet precisely when it could have, Psyche blacked out. Allow me to sketch a hypothetical outline. Imagine Atlas started exhibiting odd formations in late August or early September. Picture Psyche's shots picking up on that. Compartments unfolding, vapor bursts shooting from targeted spots instead of spreading evenly over the exterior. Shapes that clash with random natural breaks. Envision those photos getting instantly tagged by software scans or by team experts who spotted the unbelievable. What follows? Does NASA dump those visuals straight to the masses? Or do they get sealed, funneled through clearance checks, passed to military and spy outfits prior to any open reveal? Not claiming this is what went down for sure. Just noting the archive void lines up with it possibly occurring. And NASA's utter quiet on the voids cause hardly builds trust in the harmless account. You'll spot this trend echoing across our probe. Missing records, postponed drops, fuzzy pics where clear ones ought to be, lab breakdowns dragging on for months instead of weeks. It's the setup of a subtle hush, not an outright fib, but a calculated control of info streams, making sure folks only get what the powers that be deem fit for us. On their schedule, through their lens, as we stay sidelined, Atlas presses onward, its hydrogen cyanide haze growing. And no matter its actions, its evolution, we're blocked from a true look. But Psyche's outage marks just the start. Up next, Atlas's trail, or better yet, the puzzle of its actual whereabouts, and the reasons it occasionally angles in ways that defy comet basics. Section 3. The Disappearing Trail Enigma. Comets ought to be straightforward, at least in concept, despite the tricky mechanics. There's the core, a grimy ice rock clump. Nearing the sun rays warm the outer layer. Frozen bits vaporize, jumping from solid to vapor. This gas release hoists grit from the core, forming a bright haze known as the coma. Then solar wind, a torrent of ionized bits roaring from the sun at 1,000,000 miles per hour, shoves the vapors and particles clear of the core. Sunlight's push on the particles aids that too. The outcome, a trail that steadfastly aims away from the sun. The comet's path doesn't factor in. The trail follows the sun's pull, not the object's speed. This is core comet science, grasped since the 1600s. Thus, a comet's trail heading sunward signals real weirdness. The Hubble Space Telescope snapped pics of 3 Atlas in August 2025, shots that should have revealed a standard coma and trail setup. But stargazers spotted something off. Atlas sported an anti-tail, a slim streak reaching toward the sun instead of from it. Anti-tails aren't unheard of. They arise when viewing a comet from a particular viewpoint, glimpsing dust bits that have wandered into the orbital flat, fooling the eye into seeing tail segments sun-directed. It's a sightline illusion, a perspective ploy. Still, those anti-trails tend to be dim, slim, and straightforward to decode with the right angles. Atlas's anti-tail didn't slot in so smoothly. It stood out too boldly. Even, overly insistent, and Earth's vantage point in space didn't quite capture the full picture. Hobbyists following Comet Atlas noted even stranger sights. Rather than a steady, flowing tail, they spotted faint, sporadic bursts of gas, unpredictable streams shooting from the core, and an envelope that flared and faded without warning. On certain evenings, Atlas seemed lively, with a subtle trail trailing in its wake. On others, at identical solar distances, it appeared nearly dormant, just a stark dot of light surrounded by scant haze. Such variability stands out. Typically, once a comet begins venting gases, it sustains a steady activity tied to solar warmth. It shouldn't pulse like a faulty lamp unless its core, spin, or inner makeup is profoundly odd. Look at any standard comet for contrast. Consider Comet Swan, cataloged as C/2025 R2, which showed up earlier that year. Swan dazzled. Earth telescopes revealed a huge glowing halo and a classic streamer arcing sunward. Backyard imagers shared shots highlighting detailed patterns in the envelope, layers of vapor and particles expanding as the core turned and bared new frost to the rays. Swan followed comet science to the letter: vivid, dynamic, steady, stunning. Atlas, however, stays faint, unpredictable, and resists simple labels. Side-by-side photos of them wouldn't suggest their kin. One resembles a true comet. The other seems like an imitation, fumbling the act. So what's behind Atlas's odd tail antics? Start with standard theories. Breakup could be at play. If the core is splintering, bits of frost detaching from the bulk might cause uneven venting as pieces heat unevenly. Such splits often yield dust veils and sprays that briefly amp up a comet's glow before it dims. Yet breakup tends to show obvious clues. Split cores, spreading rubble, sharp brightness spikes then drops. Atlas lacks those telltale marks of disintegration. The spin rate offers another angle. Suppose Atlas rotates with outlets clustered on specific spots. We'd notice glow shifts as those spots face or flee the sun. That might account for the pulsing, though it struggles with the backward-pointing tail. Spin-driven sprays would still get swept sunward by solar gusts and light push. They could form lopsided streamers, bent ones, or even coiled designs, but nothing aimed toward the sun. Then there's the idea of electrified specks clashing with solar magnetism. Should Atlas eject oddly charged bits, electric pulls could nudge material off kilter, briefly overriding light pressure. It's unconventional, yet feasible. Comets buzz with electricity. Solar flow is charged gas. Zapped bits haul currents. Fields coil and snap. Amid that turmoil, oddities emerge. Still, this demands Atlas be oddly composed, spewing particles or vapors unlike typical ones. That loops us to the core puzzle. Why does Atlas diverge so sharply? Now we venture into theory, but one rooted in the quirks at hand. Suppose the tail isn't entirely organic? What if targeted releases are shaping it? Outlets or ports spewing vapor at set directions, generating force that warps the usual tail shape. Picture a probe using steering jets. The plume doesn't drift with solar flow. It blasts wherever aimed. If Atlas packs anything like drives, even basic vapor bursts for steering or path tweaks, those outflows would spawn noticeable jets ignoring comet norms. They might spawn the sporadic bursts, the sporadic flares, the sun-facing features baffling experts. I'm not claiming this occurs, just that it aligns with sightings more neatly than routine ideas floating around. And here's the tough reality. Should Atlas be engineered, adjusting course, managing its vents for unknown aims, then it's no inert rock we can forecast and dismiss. It's something purposeful, reacting to surroundings, perhaps unleashing its cyanide haze right when and where intended. That shifts the game. It turns Atlas from oddity to possible hazard. But to grasp the full extent of this potential danger, we must examine the organizations tasked with probing it and question their reluctance to share findings openly. This leads directly to the European Space Agency's odd approach to the data from the Mars Close Encounter. Part 4. ESA's Data Vault and the Art of Postponement. Back in early October 2025, the 3-2 Atlas comet zipped past Mars at a distance of roughly 5 million miles from the rusty world. It offered a prime chance for detailed scrutiny. The European Space Agency manages 2 advanced probes circling the planet, the ExoMars Trace Gas Orbiter and Mars Express, each outfitted with tools for probing air components and snapping pics of far-off targets. As Atlas drew near, ESA stated they'd try to gather observations, grabbing photos and spectral readings to assess the comet's makeup and behavior. This was solid, legitimate research. The comet was nearer to those orbiters than to any ground telescope on Earth, which could uncover specifics hidden from our view back home. ESA aimed their probes, trained the sensors, and gathered the info. Then began the period of suspense. On October 7th, 2025, they shared preliminary shots depicting Atlas as a tiny speck amid the stars, taken by the trace gas orbiter from about 30 million kilometers distant. These pics were hailed as a feat of engineering. See, we spotted the space wanderer right from Mars orbit, a demonstration that our gear functions well and that global teamwork in astronomy pays off. The announcements brimmed with excitement, yet they skimmed over specifics in a curious way. The images captured Atlas's location, its path through the heavens, and a subtle hazy envelope. However, they came out blurry and low-res, practically sketch-like in their simplicity. Detractors quipped that they resembled old-school Space Invaders visuals, blocky shapes on a dark canvas. For a group that regularly delivers breathtaking, sharp images of Mars's terrain, its weather patterns, and even its satellites, these Atlas visuals seemed surprisingly basic. Even more telling, ESA declared that the spectral readings, the key insights into which gases the comet is spewing, what chemical building blocks are there, and the ratios of isotopes, all that crucial info shedding light on Atlas's backstory in essence, would take months to process before going public. Months upon months. In theory, spectroscopy is pretty direct. Aim a device at the target, snag the light particles, break down the colors, and spot the lines that match familiar substances. This isn't groundbreaking work demanding years of simulations. It's standard procedure in skywatching. Sure, if tweaks for accuracy are required or if utmost precision is the goal, a few weeks ought to do it. Not this extended holdup. So what's behind the hold? Think about what those spectral results could uncover. We're aware Atlas is pumping out huge amounts of hydrogen cyanide. But beyond that, any oddball chemicals or setups that buck normal patterns. Weird isotope mixes pointing to origins mismatched with our solar neighborhood or typical cosmic voids. Clues to man-made substances, things that scream, not from nature. Spectroscopy holds the answers to such puzzles. And it seems ESA prefers not to rush those revelations. By holding back, they shape the story. They make certain that once the details surface, they've been scrubbed, explained, and worded to downplay any panic while stressing careful science. This doesn't slam dunk prove a conspiracy, but it sure aligns with bureaucratic control tactics. Contrast ESA's Atlas dealings with how they've treated fresh findings lately. When Mars Express picked up methane bursts in the planet's air, the info dropped in mere weeks, igniting heated talks on life origins versus rock-based causes. When the Trace Gas Orbiter charted steam traces in Mars's skies, the outcomes hit journals fast. Those breakthroughs thrilled folks, but they posed no real menace. They didn't upend core ideas about our cosmic backyard. Atlas changes that. A buzzing interstellar intruder belching poisons close to our turf is without precedent. Should it bear markers of human tinkering or a structure beyond natural explanation, the fallout would be immense. And maybe that's precisely why ESA proceeds cautiously, doling out bits piecemeal, gauging reactions from the public and experts prior to dropping more. There's the coordination angle too. ESA doesn't go solo. They swap intel with NASA, fellow space outfits, and even security or spy networks. If Atlas turns out wildly off-kilter, if the probe scans exposed something mind-blowing, that wouldn't linger in ESA's research wing. It'd climb the chain, get stamped secret, and spark talks at high scientists operating at levels far beyond those of public-facing researchers might receive instructions to proceed cautiously, to verify every detail meticulously, and to prevent any hasty findings from emerging, not due to some shadowy plot, but simply because organizations instinctively adopt a conservative stance when dealing with data that could spark widespread alarm or political upheaval. And let's be clear, verifying that Atlas is man-made would shake things up profoundly. It would instantly prompt a barrage of inquiries. Who constructed it? What's its purpose here? What functions is it performing? Does it represent a danger? Are there more like it? Such issues would force responses from authorities, armed forces, and global organizations wholly unequipped to handle them. Consequently, the ESA holds back the information. They share attractive images that avoid any contentious revelations. They assure everyone that in-depth reviews are forthcoming. Just wait it out. Research demands patience. In the interim, Atlas keeps advancing toward the sun, drawing nearer to our planet, while those privy to the top-tier observations remain silent about their true discoveries. Yet, we're not completely blind to the situation. We can juxtapose Atlas with similar celestial bodies. We can leverage the available sightings to construct a compelling argument. And one of the most incriminating elements arises from posing a straightforward query. If Atlas was genuinely merely a comet, how would its actions align with those of a genuine comet tracked over the identical time frame? That side-by-side evaluation is crushing. But prior to diving into that, we must confront an even more ominous scenario. What if the hydrogen cyanide envelope around Atlas isn't merely a byproduct? What if it's an intentional deployment? Part 5. The weaponized cyanide theory. Let's discuss toxic vapors in the cosmos. It evokes sci-fi tales, like a blockbuster where hostile extraterrestrials bombard our world with gas from above. But the underlying science is legitimate, and it's essential to grasp it before brushing off the idea as ridiculous. Atlas is presently generating hydrogen cyanide at roughly 4*10 molecules/s. That's a staggering figure. But to make it relatable, consider this. Gathering that yield for just 1 hour would yield sufficient hydrogen cyanide to occupy multiple Olympic-sized pools in vapor form. Across days, weeks, or months, the resulting haze would be vast. However, the void of space is immense too, and gases disperse swiftly in a vacuum. Once that haze diffuses, its density plummets sharply. The inverse square principle is unforgiving. Increase the separation twofold, and the density shrinks to a quarter. Triple it, and it's 1/9. When any haze from Atlas arrives near Earth, it would be so thinned out that spotting it would be challenging, much less suffering any poisonous impacts. Thus, the hydrogen cyanide haze from Atlas alone doesn't constitute an urgent hazard to terrestrial life. Our atmosphere offers substantial shielding. Even supposing a thick stream somehow arrived at our world, it would incinerate in the upper layers, break down into benign particles, and fail to descend to ground level in hazardous amounts. Achieving ground-level poisoning would require a deliberate, prolonged discharge straight into Earth's orbital route, paired with remarkably unfortunate conditions during atmospheric penetration. This isn't occurring by accident. However, and this forms the pivotal inquiry, could it occur by design? If Atlas is truly an artificial construct, might it guide its course and outflows to unleash a focused toxic plume at a designated site? This ventures into hypothetical yet feasible ground. Picture Atlas equipped with a propulsion mechanism, something understated, maybe harnessing expelled gases for momentum. Minor path adjustments, invisible from our vantage since we anticipate cometary paths to follow gravitational pulls, could align Atlas so that its perihelion, the Sun's nearest point, situates it squarely in Earth's orbital lane. Then, at the ideal instant, it emits a targeted surge of hydrogen cyanide, not scattered everywhere, but channeled via a nozzle or outlet directed toward Earth's anticipated location. The plume disperses, but along a path engineered to cross Earth's orbit exactly when our planet traverses that zone. Orbital dynamics collides with chemical aggression. Feasible in theory, absolutely. Feasible in practice? That hinges on Atlas's features, which remain unknown. Let's examine the technical demands. Initially, propulsion. Atlas would require a way to alter its speed marginally. Gas expulsions could suffice. Expel volatile substances unevenly, and you produce propulsion. This mirrors how certain probes manage orientation via minor thrusters that release vapor. Should Atlas feature onboard storage and steerable outlets, it could refine its trajectory. Next, aiming. Atlas would have to track Earth's current and future positions, then compute collision courses. That calls for detectors, processing units, and orbital data, nothing out of reach for any advanced space-traveling society. Finally, synchronization. The hydrogen cyanide discharge must happen at an exact juncture when Atlas is set, so the burgeoning plume Atlas crosses Earth's path precisely when it should, following basic orbital principles that are entirely calculable. Simple stuff, really. But consider this unsettling idea, the abrupt release of hydrogen cyanide at 2.1 astronomical units could be deliberate, not accidental. Perhaps it's a trial run, a diagnostic procedure to ensure onboard functions are operational, that chemical lines are intact, and that containment units remain sealed after eons of space travel with interstellar voyagers. You activate the device, test the output, observe the plume's dispersal, assess if Earth-based watchers detect it, and gauge their response. Afterward, you press on toward the inner system, collecting intel, fine-tuning aims, and biding time for the ideal deployment near perihelion. That's the blueprint for crafting a scouting and deployment apparatus. You'd incorporate backups, validation phases, and safety measures. The September release might precisely serve as such a pre-launch trial. And should that hold, the consequences are downright eerie. This isn't an inert hazard, some mindless body that just happens to pose a risk by chance. No, this is a dynamic danger, an entity that adapts to its surroundings, adheres to a scripted routine, pursues goals we can merely speculate about. The exhaust pipe comparison merits attention. Suppose Atlas harbors a massive internal drive, producing energy for thrust or signaling. That drive would expel waste. Hydrogen cyanide might emerge as a side effect, a telltale marker of the tech humming away within. Much like a vehicle's fumes betray its burning engine, Atlas's outflows could betray inner workings. And if that drive recently fired up, if components just came online, the discharge would surge forth, just as we've seen. Not definitive evidence, sure, but it weaves the sightings into a tighter narrative than mere comet dynamics. The bleakest schedule unfolds thus. Atlas slipped into our solar system in hibernation mode. A latent device husbanding power, curbing releases, masquerading as a lifeless cosmic boulder. Nearing the sun, its innards tracked sunlight levels, proximity, path. At a preset mark, around 2.1 astronomical units, startup sequences kicked in, machinery revved, tanks unsealed, hydrogen cyanide spewed. As a check and as engine startup residue. Terrestrial spotters picked up the burst, flagged the oddity, yet conventional experts chalked it up to routine comet antics. All the while, Atlas pushed closer, honing its course, nearing perihelion at about 1.36 astronomical units, where solar warmth would blaze, where innate comet outbursts would surge, offering flawless camouflage for more releases. And should Earth find itself in the path at the fatal moment, a dense vapor cloud crosses our trajectory, hitting us with a peril we overlooked by labeling it a mere comet. Let me stress, this outline rests on premises. It assumes Atlas is engineered, that it boasts unseen features, harbors motives we deduce indirectly. Yet every other account, every effort to cram Atlas into standard comet norms, fails to account for the oddities. The abrupt start to emissions, the backward trajectory hints, the probe's signal losses, the info lags. Eventually, the pileup of quirks forces us to entertain ideas we prefer to sidestep. And this one, the cyanide weapon idea, aligns with the evidence in a way that's all too persuasive. But there's a broader canvas to this. A tangle of plots and veiled motives implying Atlas could tie into something far odder. To grasp that, we must delve into Project Bluebeam. Part 6, Blue Beam Activation Sequence. One conspiracy notion stands out for its intricate, movie-like flair, captivating even the most jaded doubters, if not convincing them. It's dubbed Project Bluebeam. Believers claim it's a covert scheme by elusive international power brokers to simulate an alien assault via cutting-edge holograms, orbital projectors, and energy field tweaks. The aim? To panic global citizens into yielding to a unified world order, handing over borders and freedoms for iron-fisted rule, all in return for shielding from the invented space menace. It's the grandest hoax, a stellar smokescreen to prey on our primal terrors for power grabs. Many analysts brush off Blue Beam as baseless frenzy, blending real worries over state manipulation with pulp sci-fi elements. Still, in fringe circles, it's treated as gospel, complete with a vigilant alert system that followers monitor closely. The sequence runs as follows. Official science and press have long debunked UFO reports, mocked witnesses, and insisted that alien contact remains improbable, verging on it's hard to imagine a complete turnaround in that storyline. But suppose the tide turns abruptly, with key doubters starting to recognize the extraterrestrial reality, and officials finally confessing to monitoring bizarre aerial sightings. That kind of reversal would indicate the Blue Beam project kicking into gear, preparing the groundwork. Society's getting prepared for it. The illusion generators are revving up. By the time the simulated assault kicks off, Folks will buy into it since their reliable leaders have already confirmed that visitors from space exist. It's all about foreshadowing through media, leading straight to the real show. Once you're tuned in to spot that pivot, you start seeing it everywhere it pops up. In recent times, that's exactly what's unfolded. American authorities released classified footage of unidentified flying objects. Defense Department leaders gave sworn statements to lawmakers on mysterious sky events. Once derisive news networks that ridiculed UFO fans are now delivering straightforward breakdowns of armed forces run-ins with puzzling vehicles. The space agency revealed focused initiatives to study these unexplained atmospheric occurrences. The way society views extraterrestrials has evolved from wild theory to legitimate investigation. Devoted followers of the blue beam concept view this as solid proof. The switch is flipping. And right on cue, a cosmic visitor shows up, acting oddly, releasing harmful vapors, and resisting simple interpretations. Could Atlas serve as the trial run? Might it be the prelude? The introductory spectacle designed to get everyone ready for what's coming? We'll delve into this idea thoughtfully. Imagine the blue beam scheme is legitimate. Or at minimum, assume influential groups aim to shape opinions on space-based dangers. This object suits that goal ideally. It's authentic. Hobbyists with telescopes and expert facilities can spot it equally well. Faking something like that would be tough, given all the separate watchers monitoring it. Yet you can steer the story surrounding it. Share info selectively, highlight peculiar traits while minimizing others, and slowly ramp up widespread worry. Begin by calling it a routine space rock. Next, note those odd emissions. Then, point out how its path bucks our predictions. Finally, reveal features that seem artificial. With each update, tension builds, readying viewers for the following twist. In the end, when the big unveiling arrives, be it a faked light show assault or a scripted encounter with outsiders, people are predisposed to go along. They've been trained to anticipate the remarkable. The gear needed for blue beam remains hypothetical, yet not wholly far-fetched. Lasers from orbit might generate sky spectacles spanning vast regions, particularly after dark. Pair those with unmanned aircraft beaming synchronized visuals, and you'd mimic armadas of vessels. Factor in tweaks to electromagnetic waves, exploiting how brains respond to specific frequencies, and you could spark widespread visions or sound effects. Include dominance over reporting channels to spread the scripted tale, and you've got the blueprint for a fabricated world. Debates rage over whether such tools operate at the blue beam's demanded level, but pieces of it undoubtedly do. The real issue is if any group possesses the drive and means to unleash it. This is where Atlas slots in so eerily. To orchestrate an incursion, launching with a minor, far-off body is logical. It's containable. It avoids instant mass hysteria. It lets experts manage the rhythm. Observe responses to early oddity alerts. Measure which stories catch fire on the web. Refine your approach using instant reactions. Atlas turns into a practical experiment. A mind game trial blended with stargazing expertise. And since it's genuine, with scopes truly picking it up, non-believers can't brush it off as total invention. They must confront the evidence, account for the quirks, and wrestle with notions they'd prefer to sidestep. All the while, everyday people observe, take it in, and gradually move from outright rejection to tentative openness toward the notion that something beyond our world isn't what we assumed. Detractors of blue beam highlight rational weaknesses. Pulling off a worldwide ruse that enormous would demand unmatched teamwork among nations, cosmic bodies, defense forces, and press groups in scores of rivalrous lands. Betrayals would surely leak out. Insiders would speak up. The whole effort would crumble from its sheer intricacy, and those critiques hold weight. But ponder a different angle. What if blue beam isn't a unified plot, but a developing approach? What if separate players chasing their individual goals end up aligning on the identical method, leveraging the Space Menace tale to secure funding, manage crowds, or divert from bigger problems? No hidden alliance required if built-in motivations steer all toward identical actions. Under those conditions, Atlas doesn't have to tie into a grand scheme. It simply has to prove handy, a timely upheaval that diverse forces can leverage. All at once. I'm unsure if Project Blue Beam holds any truth. I'm unclear on whether Atlas ties into it. Yet the pattern stands out clearly. The storyline is evolving. And whenever these trends surface, when improbable events start seeming predestined, it's smart to probe who stands to gain. But hold off on the plot theory side for a second and look at a different trend, one that's been steadily recorded by stargazers for ages. One hinting that Atlas could be far from solitary. One posing a basic, chilling query. Imagine the celestial bodies up there aren't quite what we perceive. Chapter 7. The Trend of Fading Stars. Beatrice Villa Hole may not ring bells for most folks, but her studies could rank among the creepiest advances in stargazing over the last 10 years. Teaming up with ancient photo plates, those fragile glass records captured by scopes across the 1900s and stored in global observatories, Vero started matching vintage star maps against today's high-tech scans. Her aim was simple: spot items that showed up in those old shots but have since faded away. She dubbed her effort Vasco, for vanishing and emerging sources across a century of skywatching. Her discoveries deserved front-page buzz. By stacking the U.S. NOBAR's records, she pinpointed about 100 spots that looked like stars or star-resembling blips in the 1950s, yet lack matches in current charts. They just blinked out. Now, prior to jumping to extraterrestrials, consider the standard rationales. Those old plates can be finicky. The coatings break down over time. Rays from space zap fake specks. Processing fluids spawn illusions. Tiny dust bits on the panes pretend to sparkle. Weather quirks while shooting can spawn illusory shadows of nothing. These are valid issues, and Varel's group tackled them methodically. They weeded out clear fakes, verified against various plates from separate sites, and zeroed in on instances where the lost item popped up reliably in multiple shots. The outcome: a group of vanishings that defy quick fixes from gear glitches or lab mishaps. These things seemed legit back in the 1950s and truly aren't there now. So where'd they go? Official star science floats a few earthly ideas. A dud supernova might flare up a star enough to spot it temporarily before it dims into nothing. Glints off intense close-by suns could spawn bogus signals. Wild swings in star brightness might render one visible in a snapshot and hidden in the next. Tweaks in light measure tech could wrongly peg the glow of distant galaxies, letting them pass as starish when they're actually too dim for today's lists at that level. Such notions explain plenty, maybe the bulk, of those missing star hopefuls. But Villel insists a slim leftover lingers, situations where routine answers don't quite snugly apply. And that's when it sparks curiosity. Let's pretend, just for kicks, that a few of these gone objects weren't genuine stars. Let's say they were man-made glows, signals, or scouts placed in our cosmic backyard or close outer voids, active in the mid-20th century for motives beyond us, then shutting off or shifting away. How could we tell them apart from real stars? Those plates offer slim detail and reach. A dot of light is a dot of light. If a scout aimed to blend as a star, holding a constant shine without noticeable drift against the backdrop over our lifetimes, it could dupe watchers for years. Then, mission over or fuel gone, it flips the switch. The star winks out. We puzzle over it, crafting space physics tales for what was never space physics at all. This links ominously to Atlas. Should Atlas turn out engineered, a scout from alien smarts, odds are it's neither the pioneer nor the Lone Ranger. Societies geared for star hopping wouldn't dispatch one Lone Ranger. They'd deploy armadas, grids, backups. Certain scouts could play quiet watchers, settling into safe paths, monitoring and logging. Others might get hands-on, nearing suns, testing airs, probing worlds. Across ages, or eons, their uptime would fluctuate. Some would break. Some would wrap up and go dark. Some would reposition. Spotting them for us boils down to chance and grit. We could catch a quick peek, log it as a streaker or rock, then misplace it as it shifts or dims. Or view it as a subtle star mimic, clueless it's crafted until it drops from sight. The fallout is mind-blowing. If just a slice of Villa Royal's faded stars proved to be crafted gear, our sun's turf and adjacent voids team with way more company than we'd guessed. We're hardly isolated in the vast expanse of the universe. It feels more like we're part of a bustling community, one we might have overlooked entirely. That's because our tools for scanning the sky struggle to tell apart natural phenomena from engineered signals. Atlas could well be just one member of this concealed group, a single device amid a fleet. It stands out solely due to its timing, flaring to life right when our tech had evolved to spot the oddities. And supposing that's the case, the abrupt release of hydrogen cyanide from Atlas probably isn't gearing up for an assault on our planet. Instead, it could serve as a beacon, a quick dispatch meant for fellow devices, some kind of sync-up we've stumbled upon by chance. Ponder the implications. We're essentially spying on a dialogue in an unknown tongue, with speakers invisible to us and a code we can't crack. Atlas releases hydrogen cyanide, which we took for a toxic haze. Yet imagine if it's actually intelligence woven into molecular signals, detectable by instruments on other units dispersed across the solar system. Suppose the trailing haze, the unpredictable sprays, and the precise emission schedule form a complete info bundle, a rapid alert declaring, "Mission complete. All functions active. Moving to subsequent checkpoint." We'd miss it as messaging since we're hunting for radio waves or light beams, overlooking chemical outflows. Still, a sophisticated society could harness chemistry, biology, or physics beyond our grasp. They might tuck information into unconventional pathways, leveraging natural features we're only starting to comprehend. The disappearing stars, Atlas's unexpected emergence, its bizarre actions, all point to an underlying dimension of existence humming right at the edge of what we can perceive. And our growing awareness now stems from our advancements finally matching the finesse of whatever lurks beyond. But another safeguard operates here, one that curbs us from digging too far. It limits access to that vast unknown, baked into legal frameworks, upheld by authorities, and seldom challenged by everyday folks. Let's dive into who gets permission to chat with the cosmos. Section 8. Rules on broadcasting quiet. Feel free to eavesdrop on the void as much as you like. Set up a radio dish in your yard, point it upward, scan the bands, and capture any blips that come through. No problem there. Officials even promote hobbyist skywatching with radio gear. Schools share datasets from big league scopes without barriers. The cosmos never stops transmitting. Pulsars clicking away like stellar clocks, quasars shining over immense distances, the cosmic microwave background whispering at 3 Kelvin. You're welcome to tune in. However, if you're itching to broadcast, to hurl a signal into the depths, things shift dramatically. Now you're threading through a web of rules, permits, and subtle barriers that basically confine outer space since to state-approved outfits. What's the deal? If the stars are vacant, if no one's tuning in, why fuss over who shouts? The International Telecommunication Union oversees worldwide radio frequency distribution. They carve out slots for ground-based chats, orbital relays, guidance tech, and sky surveys. Certain ranges stay shielded, set aside for quiet reception so cosmic whispers aren't overwhelmed by our racket. Shooting signals, there is off-limits. Makes sense. We aim to shield key studies from clutter. Yet the limits stretch beyond that. Strong broadcasts, particularly those directed off-planet, demand extra approvals. Laws differ by nation, but in plenty of places, aiming outwards ties into telecom statutes, defense protocols, or a mix. On the surface, it's about managing airwaves and dodging disruptions. Underneath, it's about oversight. Weigh the reasoning. If leaders truly think alien minds are absent or ignoring us, there's zero need to curb outgoing waves. Hollering into emptiness hurts no one. But if they harbor doubts, if there's any chance something's paying attention, then loose broadcasting turns hazardous. Imagine a backyard stargazer with a DIY rig firing off a note that draws a reply. What if that reply sparks conflict or gets misread as aggression, sparking a cosmic clash no one's ready for? Safer to funnel all sends through controlled hubs, with defense and foreign affairs keeping watch. That's the sensible take. The suspicious one runs deeper. Officials crave sole contact privileges because they've already linked up or anticipate doing so, and they won't let outsiders complicate things. History offers examples of such blackout measures. In World War II, vessels enforced radio quiet in disputed seas to hide their whereabouts from foes. Submarines operate under a similar principle in the ocean depths. The identical reasoning holds true for outer space. Should adversarial probes be lurking, eavesdropping, pinpointing origins of smart signals, then each transmission we emit acts as a signal flare, a precise locator. Staying quiet means enduring. Yet we haven't stayed quiet. For more than 100 years, humankind has been unwittingly emitting signals. From radio waves and TV broadcasts to radar pulses, all of it seeps outward, proclaiming our location. Any advanced civilization nearby, equipped with fine-tuned detectors, is already aware of us. Thus, the case for mandatory quietude falls apart unless the goal isn't concealing our being, but regulating the substance of deliberate communications. Let's ponder possibilities. Imagine that officials picked up unusual transmissions years back. Faint rhythms amid the static hinting at deliberate creation. Picture them reacting discreetly, cautiously opening a covert line of exchange with entities beyond. Envision that exchange persisting today, handled by secret divisions, using bands inaccessible to civilians. In such a setup, amateur attempts at deep space messaging pose a risk, potentially interfering with fragile talks or exposing details meant to stay hidden. Those rules aren't merely for managing airwaves. They're designed to safeguard confidentiality. And should Atlas belong to that concealed network, a device dispatched by those we've contacted, its abrupt awakening could tie to a dispatch we issued or got. A diplomatic shift from mere talk to tangible steps. I chatted with a hobbyist radio enthusiast who voiced irritation over these limitations. He'd assembled an impressive setup of antennas able to catch faint echoes from the cosmos. His plan was to run personal SETI scans, scanning for anomalies, and if anything caught his eye, he aimed to reply. But digging into the rules for beaming signals off-planet, he hit roadblocks. Regulators required in-depth tech details, pressed for reasons behind the broadcast, and in the end, steered him away from trying. The implication rang loud. Observing is okay, replying is off-limits. He saw this as proof that officials aim to block ordinary folks from direct contact with possible alien minds. And perhaps he's onto something. Perhaps the quiet rules aren't to shield us from outsiders. Perhaps they're to shield the truth from our view. Now, link this to Atlas. With public broadcasts curbed, only approved groups can send to the stars, meaning whatever Atlas picks up, whatever codes it's adhering to, stem from official channels. We're not mere bystanders to Atlas's actions. Unwittingly, we could be involved in a dialogue directed by bodies beyond public scrutiny. And should that dialogue sour, should Atlas mistake a pulse for aggression or get baffling directives, we'll face the fallout without grasping the trigger. The no-broadcast policy keeps us in the dark. And when facing cosmic dangers, blindness is the riskiest stance imaginable. But such blindness may not last. Atlas nears perihelion, its nearest solar pass, and that's when events might spiral past control. Chapter 9. Solar Interference at Closest Approach. Perihelion marks Atlas's peak exposure to the Sun's forces. Forecasts pin its minimal distance at roughly 1.36 astronomical units from the Sun, slated for late November 2025. That's around 127 million miles. Far enough from Earth's path to stay safe, yet deep in territory where sunlight surges intensely. For a typical comet, this phase sparks maximum vigor. Ices on the surface vaporize swiftly. Dust output surges. The surrounding haze swells to peak luminosity. Tails stretch across millions of miles. It's the comet's spotlight, a short burst of spectacle before retreating to the chilly fringes. But if Atlas defies comet norms, if it's a constructed entity with built-in tech, perihelion might signify far more. It could serve as the ignition phase, when sun-fueled components hit full readiness. The sun goes beyond mere illumination. It's a nuclear forge emitting across the full EM range, from low-frequency waves to high-energy bursts. It unleashes solar wind, a hypersonic flow of charged particles racing at 1,000,000 miles per hour. It forges shifting magnetic zones that erupt in solar flares, hurling vast plasma blobs that can scramble orbits and black out grids upon Earth impact. And vitally, it supplies energy. Photovoltaic arrays transform light into current. Vessels in the sunward zones rely on it. Plentiful, steady, fuel-free. If Atlas features solar collectors or analogous harvesters, its energy yield ramps up sharply as it draws nearer to the out there at 1.36 Australian dollars from the sun. The sunlight hits with about half the intensity we get on Earth. That's still more than enough to juice up power cells, wake up idle mechanisms, and run through scheduled tasks. Picture this. Atlas got built to go into deep sleep mode for its long haul across the stars, saving power, cutting down on any leaks, and floating silently for hundreds of years. Once it slipped into our solar system, built-in detectors quietly tracked the rising solar energy. When it crossed that set limit at 1 Australian dollar, basic functions kicked in, releasing hydrogen cyanide, maybe as a check or just a side effect. As it nears its closest approach to the sun, the main gear is gearing up to fire. No matter what mission Atlas came for, it'll carry it out right when the sun's output is strongest. That might mean sending out smaller scouts, beaming info home to wherever it started, tweaking its path for a run-in with a planet, or unleashing something we haven't even dreamed of. And this all lines up with when a regular comet would be at its liveliest, offering ideal cover. Skywatchers would figure Atlas is just getting brighter, spewing more vapors, acting all wild. Nothing out of the ordinary. Weird stuff would get chalked up to comet quirks, not some engineered meddling. There's more to it, too. The sun's own mood swing. It follows an 11-year rhythm, swinging from solar max, packed with sunspots, bursts, and coronal mass ejections, to solar min, when things calm down. Right now, we're heading toward the upcoming peak, slated for 2025 or 2026. So Atlas's solar closest point syncs up with amped-up solar drama, raising chances for those flares and ejections. If Atlas is rigged to tap into or respond to sun events, this schedule is spot on. A perfectly timed ejection could dump a wave of charged stuff, powering up gear, starting routines, or even hiding Atlas's own output in the cosmic chaos. Folks on the ground would have a tough time picking out man-made signals amid the solar static. Total stealth. Think about a nightmare setup. Atlas hits its perihelion in late November. A decent-sized ejection blasts off from the sun, heading out. Atlas's route puts it smack in the way. The plasma blob swallows the thing, hitting it with an EMP and a rush of zapping particles. The onboard tech, tuned for exactly this, springs to life. Ports swing open. Pent-up chemicals shoot out in aimed bursts, creating push. The craft shifts course, now locked on a precise crossing with Earth's path. At the same time, extra vapor clouds, laced with heavy hydrogen cyanide, spray in directions meant to catch up with Earth down the line, weeks or months out. To us, it looks like a comet flaring up as expected near the sun, maybe cracking a bit, showing off vigorous tail action. We miss that it's steering, aiming, turning its fumes into ammo, until it's way too late. Does this hold water? On the physics side, sure. Space paths can be nudged with targeted boosts. The chems supply the fuel. Sunlight delivers the juice. The big if is whether Atlas has the smarts built in. And we can't tell because the info's buried, lagging, or brushed off. NASA's Psyche mission lost signal in the prime viewing slot. Agency holds back on spectrum scans. Hubble shots reveal oddities dismissed as optical tricks. The setup for this catastrophe is locked and loaded. Only the motive's unclear. If it's a scout craft, is it out to get us, or just cold and mechanical, running scripts that accidentally endanger everything? Doesn't matter. Perihelion's the turning point. Come late November, Atlas's path is fixed. If trouble's brewing, it kicks off there, and we'll be glued to our screens, powerless, wishing the oddities turn harmless, but bracing for the chance they're not. So how do we spot the danger? How do we tell a space rock from a strike tool? Simple, by measuring against the norm. And that's our next move. Part 10. Baseline check. Swan against Atlas. The clincher. Science moves forward by weighing one against another. You can't flag something as off by staring at it alone. You do it by stacking it next to the standard, proving the gaps go beyond random noise. Control setups and tests? Same deal. Astronomers log hordes of bodies to map what's average. Spot a big outlier? Dig deeper. Comet C/2025 R2, aka Swan, makes the ideal benchmark for Atlas. They're both icy wanderers. Both lit up in 2025. Both eyed by the same gear. But their antics? Night and day. Swan showed up in the sun's neighborhood early that year, spotted in wide-angle shots from the Solar and Heliospheric Observatory. It was a crumb from a bigger comet that split ages back, now barreling on a path to swing within a few million miles from the sun's surface. Astronomers foresaw dazzling displays as Swan neared its closest solar pass in March 2022, and their expectations were fully met. The comet formed an enormous coma, a luminous envelope of gas and dust, that backyard observers could spot easily. Its tail stretched out over millions of miles, a stunning trail of charged particles driven by the sun's winds, snapped by hobbyists around the globe. The European Space Agency's SOHO probe recorded Swan's ultimate dive sunward, observing its sharp surge in brilliance, partial evaporation, and possible breakup or reduction to a tiny leftover core. Swan embodied the ideal comet: vivid, dynamic, reliable, and stunning. Now consider Atlas. Unearthed in 2024, this visitor took a distinct path, arriving from beyond our solar system rather than the Oort cloud like Swan. Its path was hyperbolic and unbound, so post-perihelion, it would exit forever unless altered in speed. That's intriguing on its own, though not entirely novel. We've encountered prior interstellar guests, like Oumuamua in 2017 and Borisov in 2019. Atlas stands out due to its behavioral pattern. For much of its inbound journey, it stayed dim and elusive, with scant signs of cometary traits. No vivid coma or clear tail, merely a subdued glow that intensified gradually near the sun. Then, in mid-September 2025 at 2:1 Australian dollar, hydrogen cyanide output surged unexpectedly. Not the usual water vapor or carbon monoxide from typical comet ices, but this scarcer, more reactive substance emerging out of nowhere. Examine the visuals side by side. Swan's coma shines brightly and evenly, growing steadily as material ejects from the core. Atlas's version is subdued and lopsided, with jet streams hinting at patchy releases instead of even evaporation. Swan's tail follows classic form, curving elegantly anti-sunward under the influence of light pressure and solar breeze. Atlas's is unpredictable, flickering in and out, at times even curving sunward against expected dynamics. Present these snapshots to an expert without background, and they'd peg Swan as a textbook comet right away. Atlas would spark curiosity. What's the deal with this thing? Why the odd actions? Data glitch? The visibility gap is just as pronounced. Swan hit naked eye status, peaking at magnitude 3 or 4 from clear skies. Atlas lingers at magnitude 10 to 12, needing solid amateur gear to pick up. This counts because luminosity ties to vigor. A sparkling comet means vigorous outgassing and dust ejection. A subdued one seems mostly inactive. Still, Atlas pumps out hydrogen cyanide at astonishing levels, 4 times 10 to the power of 25 molecules per second. So where's the dust? Where's the bounce-back sunlight that ought to amplify its shine? Perhaps its core is exceptionally murky, soaking up light instead of scattering it. Or maybe its output leans heavily gassy, skimping on the dusty bits that light up comets. Either scenario breaks the mold. Here's the key twist. If both Swan and Atlas arose as ordinary comets from identical cosmic mechanisms, their traits should align, adjusted for scale and makeup. Yet they diverge sharply. Swan tracks flawlessly with ages of comet lore. Atlas acts like a deviant, a puzzle defying norms. Sure, you might claim it's merely an eccentric natural body, that comet diversity runs deep and our knowledge has gaps, and that's valid. But layer in the cyanide burst, the backward-pointing tail, the probe's signal losses, the lagged readings, the abrupt wake-up at a precise range, and the oddities pile up. Eventually, chalking it to mere quirks feels less tidy than exploring other ideas. And positing Atlas as constructed, with deliberate programming, ties the observations together more neatly. We'll circle back to this matchup as Atlas nears perihelion in late November. Should it flare up suddenly, sprout a huge coma and tail, and mimic Swan's playbook, the quirks might just prove initial oddities settling into standard comet fare. But if the inconsistencies persist, if cyanide output ramps without glow boosts, if the tail stays bizarre, if fresh mysteries emerge, the argument for something engineered gains force. This probe isn't wrapping up, it's halfway. We're tracking live as evidence builds, as Atlas unveils more, as clarity edges closer. Meanwhile, as we monitor Atlas, breakthroughs in science and tech are subtly redefining the boundaries of what's feasible. The landscape of 2025 feels more alien than just half a decade back. Step back for a broader view, because surrounding details shift the picture. Letters. The cosmos doesn't function in a bubble, and neither does Atlas. Chapter 11. Artificial intelligence foresees the downfall of fusion ventures. Back in October 2025, a group of researchers from MIT dropped a grim report, employing AI algorithms to gauge the prospects of private firms chasing fusion power. The phenomenon fueling stars has tantalized humans for almost 100 years. Master sustainable fusion here on our planet, and you'd unleash virtually endless, eco-friendly electricity. Deuterium can be harvested straight from ocean water. Helium leftovers pose no radiation hazards. Zero carbon output, no danger of core meltdowns, just plentiful energy. For ages, fusion stayed stuck in the always 30 years off zone, a staple quip among physicists. Yet during the 2020s, startups jumped into the fray. Commonwealth Fusion Systems, TE Technologies, Helion Energy, and scores of other outfits fueled by tycoons and investors, all vowing market-ready fusion come the 2030s. That MIT report threw a bucket of ice on the excitement, drawing from economic simulations, engineering evaluations, and past patterns in energy tech rollouts. The machine learning forecast? Roughly 70% of these outfits would fold by 2030, tripped up by insurmountable tech hurdles or cash shortages. How does this tie into Atlas? Simple. Energy equals influence, both in raw terms and on the world stage. Who holds the reins on power sources shapes global leaders, booming economies, and the divide between prosperous lives and dire straits. Fusion's triumph would spread energy access wide. Nations with know-how could erect their own plants, slashing ties to oil, fissile materials, and strategic bottlenecks. But should fusion flop? If these ventures crumble and the vision fades once more, the old hierarchies hold firm. Petroleum states keep their sway. Fission-based plants, plagued by refuse and security worries, linger on. Solar and wind setups, hampered by their on-again off-again nature, still demand huge network overhauls. Business as usual prevails. Against this backdrop, something alien like Atlas turns handy. Picture a situation where leaders must explain massive spending, tighten grips on authority, and unite folks against a shared foe. An extraterrestrial device, a stellar peril, a rogue gadget heading our way. The ideal storm. Think about the schedule. Fusion outfits hit rough patches in 2025. AI projections say most will tank by 2030. Atlas shows up in 2024, powers up in 2025, nears its closest solar pass late that same year. Should Atlas ramp up, if it morphs into a headline-grabbing danger, officials might proclaim a worldwide alert. Funds shift gears. Public fusion efforts face takeover or cuts. Defense agendas take precedence. Cosmic shields become the excuse for spending sprees unseen in history. And handily, the indie fusion world, poised to level the energy playing field, wither away from investment droughts. I'm not saying it's some grand scheme, yet systems can yield shady results without plots. Motives match up. Turmoil gets leveraged. The AI's doom call for fusion newbies might stand true in isolation, but it highlights a fragile era, a stretch of doubt in our power prospects where panic might steer decisions over hope. Layer on more. If Atlas is man-made, dispatched by a superior society, what intel would they have on us? If they've watched our world for years or ages, they'd grasp our power woes. They'd spot our burn fossil habit, our sluggish fusion gains, our splintered alliances. A mind aiming to shake or steer us could pick the prime moment to step in, hitting when we're most off guard, as tech hopes fray when rifts widen. Atlas's debut in the mid-2020s, amid this fusion haze, escalating worldwide strains, mounting weather and money woes, feels like wild luck or deliberate play. And I've lost faith in pure chance. This goes beyond Atlas alone. It's about seeing that doomsday risks don't pop up solo. They tangle with ongoing messes, heighten them, prey on weak spots. Be it a scout, a strike tool, or just space junk, we've misread it. How it shakes human society hinges on surroundings, and those in 2025 encompass a teetering energy landscape, shaky international ties, and folks growing wary of power brokers. Atlas might ignite a tinderbox, yet power's not the sole odd frontier. Time to look to the void amid constellations, where unseen beasts glide quiet, poised for unveiling. Chapter 12. Update on the Milky Way's wandering black hole. Black holes rank as the galaxy's top hunters, pulls so fierce that light itself can't break free. reality twisted into an inescapable snare at the boundary of a black hole's event horizon. The usual principles of cause and effect cease to function. The majority of black holes we've identified fall into two categories: those with stellar masses, ranging from 10 to 100 times that of the Sun, which emerge from the dramatic implosion of enormous stars during supernovae explosions, or the colossal supermassive varieties, boasting millions to billions of solar masses, positioned at the hearts of galaxies like immense forces of annihilation. These kinds reveal themselves through intense interactions with nearby matter. Black holes of stellar scale frequently reside in paired star systems, siphoning material from orbiting partners via gravitational drag, which superheats the infalling substance to millions of degrees via friction and pressure, causing it to radiate intensely in X-rays. Their supermassive counterparts fuel quasars by consuming vast quantities of gas and dust equivalent to whole solar systems in swirling accretion disks, emitting radiation across the full range of the electromagnetic spectrum with brilliance that surpasses the output of entire galaxies. Yet, isolated black holes present a different challenge, those roaming solo through the void of interstellar space, neither consuming nor emitting light, detectable solely by their subtle gravitational pull. The true number of such wanderers remains a mystery. Direct observation eludes us entirely. They produce no signals, bounce back no light, and manifest as pure nothingness amid the universe's glow. Detection occurs only when one drifts across the line of sight to a distant star, temporarily amplifying its brightness via gravitational microlensing, an effect foreseen by Einstein, in which hefty bodies warp spacetime to form an organic magnifying glass that concentrates and intensifies rays from farther away objects. This phenomenon proves faint, fleeting, and demands remarkable fortune to witness. In September 2025, researchers poring over observations from the Hubble Space Telescope alongside terrestrial surveys reported spotting a free-floating black hole of about 12 solar masses meandering through our Milky Way, positioned some 4,000 light-years distant from our planet. The find stemmed from a microlensing episode spanning months, during which a far-off star's illumination fluctuated in a manner matching the transit of a hefty unseen body between it and Earth. Through scrutiny of the light curve, the detailed timeline of intensifications and fades, along with the event's length and the extent of the boost, scientists determined the interloper's mass and speed, 12 times the Sun's mass, cruising at around 100,000 miles per hour compared to nearby stars. This specimen qualifies as a true rogue, likely hurled from its origin point by an uneven supernova that imparted a powerful gravitational shove. It now prowls the galaxy undetected, revealed only by rare spatial coincidences. The computational efforts to pinpoint this entity were daunting. The team sifted the black hole's telltale signs from myriad interferences, including fluctuations in stars themselves, equipment glitches, and distortions from Earth's atmosphere. They corroborated findings across various observatories, confirmed the occurrence with separate datasets, and simulated rival explanations to rule them out. No planet could generate such a light profile. A faint star would exhibit distinct color shifts. Nothing but a black hole aligned with the evidence. This breakthrough capped decades of meticulous effort, involving automated scans tracking millions of stars at once in hopes of catching the distinctive mark of lensing. The revelation prompts a troubling inquiry. With one rogue black hole uncovered via microlensing, how many others lurk unseen? Spotting these demands exquisite precision in positioning. The black hole, the target star, and our vantage point must align to within a fraction of a milliarc second, tinier than distinguishing a dime from 1,000 miles off. The probability of lensing for any specific star at any instant is vanishingly small. Thus, unearthing even a single one hints at a vast hidden hoard. Projections indicate that tens of millions of stellar mass black holes may traverse the Milky Way, clustered mainly in the dense plain of star birth, with others scattered in the outer halo, all cloaked unless they fortuitously lens a star or snag some material to feed on. We navigate an ocean of unseen gravitational snares, aware of them only when our path crosses their narrow observational window by fluke. Ponder the consequences. Spanning about 100,000 light-years and harboring hundreds of billions of stars, our galaxy hosts these tens of millions of black holes dispersed throughout. On average, they might separate by just a few dozen light-years, near enough to pose real threats to any voyage between the stars. A probe venturing across the cosmos would require charting these phantom barriers, devising ways to sense them, and plotting courses to evade them. And since we're scarcely starting to identify them through microlensing, how might a starfaring society contend with this? They would rely on sensing technologies vastly superior to ours today, maybe detectors for gravitational waves attuned to the subtle ripples from lone black holes, or groundbreaking principles yet to be unveiled. We often presume a solid grasp of our solar system's contents. Through years of meticulous observations, we've mapped out asteroids, comets, and Kuiper belt items. We monitor near-Earth bodies that could spell trouble in terms of impacts, compiling records of asteroids that carry potential dangers. We believe our inventory is fairly complete. Yet, if the Milky Way harbors unseen black holes that only recently come into our view, what other secrets could elude us? Shadowy, lightless bodies that evade our spotting techniques, devices that suppress their radio signals, or constructed forms that mimic ordinary space junk. The finding of that wandering black hole serves as a stark reminder. Lacking proof doesn't prove non-existence. Simply put, failure to detect something doesn't confirm its absence. It could merely lurk beyond the reach of our present tools, hidden in blind zones we haven't yet identified. I'm not claiming Atlas is some black hole. It plainly releases luminous gases, picked up by scopes scanning various spectra. Still, the underlying idea holds true. Atlas popped up abruptly in our monitoring setups, first labeled a comet since that's what our survey instruments are tuned for. Had it stayed quiet, without sparking its hydrogen cyanide output right then, it could have slipped past the inner solar system unseen, like yet another dim asteroid on a hyperbolic path, too tiny and obscure to ping our automatic alerts. Spotting it today feels somewhat serendipitous, hinging on its flare-up occurring when and where our gear could capture the signal. Over the course of human existence, how many similar Atlas-like wanderers have crossed the inner system without notice? How many linger out there currently, inactive and unseen, biding their time until they activate or we invent detectors keen enough to uncover them? That stray black hole also highlights the universe's impartiality. The 12 solar mass entity has no regard for Earth. It's not aimed at us. It simply wanders, guided by gravitational paths, born from stellar events eons in the past. Should its course cross Earth's orbital lane just as we're there, catastrophe would follow. Not from spite or intent, but pure misfortune, a chance stellar overlap. Atlas could mirror this. It may not represent a strike directed at us humans. Perhaps it's a scout adhering to an ancient itinerary, running long-set protocols, and we're merely in its way. Motive becomes irrelevant if the result proves devastating. A projectile requires no animosity to end a life. Recognizing that the cosmos doesn't orbit around us, that celestial bodies and beings follow their courses without concern for our fate, proves both sobering and alarming. It compels us to face our minor role in the grand scheme. We're no focal point of the universe, no apex of stellar development, just one life form on one world, possibly exposed to powers and presences we scarcely fathom. This insight ought to shape our views on Atlas, on alien encounters, on our cosmic standing. And it resonates in fresh breakthroughs elsewhere, especially physics, where we're uncovering that existence may follow rules we only dimly perceive, with quantum rules and Einstein's theory suggesting profound layers just starting to emerge. Part 13. Quantum time crystals mark initial real-world application. Quantum physics defies common sense. No exaggeration there. It's just factual. Subatomic bits dwell in overlapping states, holding several possibilities at once until measured. Linked particles influence each other right away over vast gaps, challenging everyday notions of space. The uncertainty rule caps how sharply we can pinpoint details. And here in 2025, researchers have showcased enduring time crystals, a material state so odd that even quantum experts once doubted their feasibility. A time crystal displays rhythmic patterns over time, beyond mere spatial repetition. Everyday crystals, say table salt or gemstones, Feature atoms in recurring layouts across space. Disturb one, and it rebounds to stability. But a time crystal keeps pulsing endlessly, shifting through phases sans added power, refusing to rest in balance. Its endless rhythm at zero energy expense forms a sort of time-based symmetry that appears to flout heat laws, though it sidesteps them by thriving in unbalanced setups, precisely tuned to leverage quantum quirks. At first glance, the notion seems absurd. Perpetual motion gadgets have long been rejected as pipe dreams, barred by energy conservation and rising disorder in sealed environments. You can't generate power from void. Chaos invariably grows in isolated realms. Nevertheless, time crystals navigate these barriers by operating in open and quantum setups where energy circulation keeps them in a distinct phase, far from equilibrium, yet locked into enduring vibrations that last forever. Imagine it as the quantum equivalent of a world circling its sun. Once initiated, the movement goes on endlessly without fresh energy boosts, though it's not conjuring power out of thin air. The setup starts with starting parameters that allow this endless loop. Back in March 2025, engineers at Google's quantum AI facility revealed they'd formed a time crystal inside their Sycamore quantum chip, holding steady for more than 100 vibration rounds, vastly outlasting prior efforts. Pulling this off demanded pinpoint mastery of quantum conditions, tweaking single qubits via laser bursts synced to femtosecond accuracy. The team showed the setup pulsed at precisely half the input frequency, a defining trait of time crystal dynamics. And vitally, this rhythm held firm even amid deliberate disturbances meant to throw it off. The time crystal displayed impressive resilience, auto-adjusting to keep its rhythmic sequence intact under pressures that would shatter typical quantum configurations. Come August 2025, scientists at MIT unveiled a time crystal functioning at ambient temperatures, built from a grid of nitrogen vacancy sites in diamond, a design ripe for expansion into usable tech. This advance ditched the demand for temperatures near absolute zero and rare superconducting gear, shifting time crystals from niche lab setups to settings where everyday uses could actually work. The diamond grid method harnesses flaws in the lattice, spots where nitrogen swaps in for carbon, yielding quantum elements that stay intact at room temp. These nitrogen vacancy spots get tuned with microwaves and lasers, nudged into time crystal modes that hum along with exceptional steadiness. Far from mere trivia for science mags, time crystals hold game-changing potential for quantum tech, offering qubits that fend off decoherence, the core hurdle blocking quantum machines from growing to practical scales. They might power super-accurate detectors, timepieces that avoid quantum-level drift, data holders that don't fade since the info lives in time-based loops instead of fixed positions. And on a bolder note, they could fuel innovations we can't yet picture, tapping time's architecture in forbidden classical realms. Certain models hint at roles in quantum signaling schemes, spotting gravitational ripples with unmatched sharpness, or even exploring time's core essence. So why tie this to Atlas? If Earth researchers nailed time crystals by 2025, picture what a sophisticated alien society might have pulled off ages or eons back. Should Atlas be engineered, its guts could run on physics we barely grasp. Time crystal hearts might deliver reliable power reserves, unified quantum setups for processing or signaling, or tools for gently bending spacetime. We'd miss these feats from the outside view. Cracking it open, scanning materials down to the atom, and probing its mechanics firsthand would be essential. But afar, we'd spot oddities, actions defying natural explanations, outputs mismatched to standard heat or chem reactions, paths implying control sharper than mere gravity. Take the hydrogen cyanide output. We chalk it up to sublimation, ice warming, and turning to gas as Atlas nears the sun. Yet suppose it's a side effect from a time crystal power setup? What if Atlas employs a quantum method producing leftovers, with HCN as one? The release profile, abrupt start, and ongoing yield might mirror the mechanism firing up, not sun warmth. That accounts for the output's loose link to solar proximity, its sharp emergence instead of slow ramp-up per heat forecasts. It stemmed from tech, not heat. And with time crystal tech in play, it could run ultra-efficiently, barely wasting power, enduring spans that dwarf old-school energy tech. The power math speaks volumes. Chem processes hoard energy in molecular ties, freed by burning or reactions. Nuclear ones draw from nucleus glue. Both are irreversible. Fuel gone. That's it. Time crystals differ, sustaining their vibes eternally post-start, needing just tiny nudges to counter outside interference. For a craft void traveling across the cosmos, such an innovation might distinguish between a lifespan of mere decades in service and an astonishing span of millions of years. A power setup based on time crystals wouldn't generate propulsion. You'd still require fuel for that. Yet it could energize onboard computers, detection gear, transmission devices, and steering controls virtually indefinitely. Imagine Atlas setting off back when early humans huddled in caverns. It could remain entirely functional right now. Let me stress again, this remains pure conjecture. There's no proof that Atlas incorporates time crystals or any cutting-edge quantum tech. Still, the 2025 breakthrough in creating time crystals pushes the limits of what's conceivable. It prompts a fresh look at technological possibilities. Just 5 years back, time crystals existed only as intriguing theories, abstract models that scientists argued might defy core physical principles. Now, we've seen them realized in labs, with real-world uses emerging soon. Project that advancement over hundreds of years, in a society boasting far superior resources and insights compared to ours, and the chasm between their tech and ours yawns enormously. Atlas might resemble our modern smartphones in contrast to primitive stone implements. We can tell it's functioning in some way. We can quantify certain results, but decoding its mechanics? Unraveling the core concepts could lie entirely outside our present intellectual grasp. One more angle deserves attention. Time crystals upend our grasp of entropy, the relentless march of time, and the tendency of systems to slide into chaos. They hint that, in specific scenarios, behaviors akin to perpetual motion can occur, all while respecting quantum rules. Should an advanced society harness this, they might craft devices that run endlessly sans replenishment. Spacecraft that glide through the void for eons, staying operational, poised for wake-up signals. Atlas's seeming inactivity en route, then abrupt revival, aligns seamlessly with this idea. A core powered by time crystals could sustain basic functions eternally, just sufficient computing to oversee detectors, verify location, plot paths, then surge to peak performance upon sensing ideal triggers, such as nearing a star or detecting telltale EM patterns from a tech-savvy society. We've been viewing Atlas via the filter of standard physics and engineering norms, shaped by our modest forays into space. Yet it could rely on concepts we're only starting to uncover in our top-tier research facilities. That we're unearthing these ideas at all implies they're not utterly alien, merely sophisticated. They mark an elevated step on the tech progression ladder, a level any determined scientific culture would climb in time. And since we're already approaching some of these breakthroughs, what further innovations might lie ahead? Which other developments in our labs could mirror alien tech? What feats could we pull off in the coming century that would strike today's us as outright sorcery? As it happens, we're tinkering with cloaking tech that feels eerily pertinent. Part 14. China's hypersonic plasma shield patent. Back in early October 2025, experts in defense spotted a patent submission from a Chinese aerospace lab outlining a plasma-driven protective layer for vehicles screaming along at hypersonic speeds. Curiously, the details weren't redacted, hinting at either a calculated reveal to unnerve competitors or a bureaucratic slip-up that exposed classified intel to public eyes. Here's how it operates. When a hypersonic craft slices through the air at Mach 5 or beyond, the intense drag superheats the surrounding atmosphere into plasma at scorching temperatures in the thousands of degrees, forming a luminous envelope around the craft. This plasma inherently disrupts radar signals, complicating detection efforts. However, it also triggers radio silence, blocks heat-based surveillance, and inflicts brutal thermal stress on the structure, challenges that have bedeviled engineers for generations. The Chinese filing proposes employing electromagnetic forces to mold and steady this plasma layer, flipping a liability into a strength. Coils producing magnetic fields direct the plasma into tailored shapes, forming areas of thick ionization that repel approaching EM waves, functioning much like a barrier against radar and energy-based arms. The specs outline a layered strategy, with varied field patterns fine-tuned to counter diverse dangers. For radar threats, the plasma yields a hazy, ever-morphing facade that bounces back signals in erratic patterns. Versus lasers, the charged particles soak up and scatter the focused beam, diffusing its power to safeguard the craft's exterior. It's a clever fusion of physics turned into a defensive tool. The patent advances even more, proposing that the setup could work in outer space goes beyond mere atmospheric conditions. Install comparable magnetic field creators on a vessel, introduce ionizable gases like xenon or argon into the nearby void from internal storage tanks, and you've formed a synthetic plasma envelope. Such an envelope could deflect radar waves, neutralize laser attacks by ionizing prior to contact with the exterior, and possibly disrupt particle streams or EMP assaults. It's far from the impenetrable barriers of sci-fi starships. Solid projectiles still pose a threat, yet against electronic disruptions and focused energy weapons, the approach proves highly potent. Moreover, the patent suggests the method has advanced to the point of readiness for trials, perhaps even integrated into prototype vehicles. The ramifications for orbital battles, safeguarding satellites, and operations involving asteroid or comet deflection are immense. Yet there's a deeper concern that defense experts hesitate to voice openly. Should China be advancing plasma barriers for space vehicles, it's possible that existing extraterrestrial objects possess them as well. Picture Atlas encased in a slender layer of charged gas, sustained by embedded magnetic field producers. This ionized coating would complicate remote spectroscopic identification. Photons traversing the plasma undergo diffusion, uptake, and re-emission across varied spectra. Spectral profiles become indistinct. Radiative signatures get concealed. Those subtle, irregular signs we attribute to comet-like behavior could in fact represent advanced concealment, with the plasma barrier regulating electromagnetic output to render Atlas less luminous and more unpredictable than reality warrants. The hydrogen cyanide traces we observed might represent merely the minimal seepage past the barrier, as most outflows remain captured, charged, and regulated by the protective mechanism. This accounts for Atlas's dimmer appearance relative to its estimated gas output. It's not inherently shadowy. Rather, our view is filtered through an intentional haze, a crafted obscurity that dictates the data arriving at our observatories. The Chinese filing also addresses employing plasma barriers to counter high-speed collisions from minuscule particles at satellite velocities. In the vacuum, even minute fragments can breach alloys at such paces. The plasma wouldn't fully evaporate the fragments, but it might charge their exteriors, marginally altering their course or diminishing their momentum by eroding the surface coating. For an interstellar traveler like Atlas, enduring voyages spanning centuries or eons, micro-impacts from meteoroids present a genuine peril. Across millennia, repeated strikes would erode even the toughest surfaces, damaging photovoltaic arrays, scarring viewing instruments, and risking overall stability. A plasma barrier would serve as superb protection, ensuring the craft's endurance amid innumerable encounters. If Atlas employs this defense, it could intensify the field nearing the sun, shielding from heightened solar wind and radiant exposure. Observers might perceive this as amplified plasma glow, mistaking it for cometary outbursts, oblivious to the underlying adaptive safeguards responding to ambient perils. The setup would operate independently, reacting to inputs from detectors on debris concentration and radiation intensity, modulating barrier potency as needed. Now, indulge in some speculation briefly. The date of this Chinese application, October 2025, raises eyebrows. Atlas began emitting hydrogen cyanide in September 2025. Shortly after, China submits a public disclosure on plasma defense systems that oddly aligns with several of Atlas's peculiarities. Mere chance? Perhaps. Or perhaps experts in Chinese space monitoring, using superior military optics beyond public scopes, spotted traits hinting at plasma defenses. They could have deduced the principle from afar. Alternatively, they might have pursued it separately and found Atlas corroborating their design. Regardless, the submission broadcasts to global powers. We're aware of extraterrestrial capabilities. We grasp the tech and are devising responses. It's a strategic message embedded in engineering specs, and it implies that secret surveillance of Atlas yields insights far richer than open-source data. Reflect on the capabilities of defense-level orbital watchers. Public instruments log luminosity, paths, and emission profiles. Armed forces enhance this with thermal imaging, EM profiling, and even subtle gravitational distortions. Should Atlas produce robust magnetic fields to hold plasma, those would register on precise flux detectors. If it dispenses chargeable gases, detailed spectral scans could uncover isotope patterns at odds with typical comet chemistry. Defense evaluators may have flagged these oddities long before, assembled them into secure briefs, and initiated defensive strategies, all without public disclosure. The general populace remains in the dark. That Chinese patent could fit right into this quiet contest of innovations. It's a step to claim first dibs and hint at advanced prowess. But consider a more ominous possibility. Suppose the plasma barrier isn't merely protective? Imagine if it's geared for attack. A robust plasma enclosure, powered up by electromagnetic forces, might serve as a targeted energy device. Mold those forces to concentrate the plasma into a stream, and you've got an ultra-hot stream that can slice through substances, jam electronic systems, or even harm living matter. Should Atlas possess this kind of setup, the hydrogen cyanide vapor could pale as a side issue. The real danger might lie in the electromagnetic realm, a plasma-based armament that kicks in at closest solar approach when sunlight hits its strongest, aiming a power surge at our planet or orbiting assets that we're utterly unequipped to counter. Our existing tracking tools wouldn't catch wind of it. We're on the lookout for physical collisions, orbital shifts, or blatant armaments. Subtle electromagnetic accumulations or odd magnetic patterns near Atlas. Not so much, since we view it as a comet, and comets aren't supposed to pack firepower, though this one potentially does. Here's how the science lines up. As it nears the sun's closest point, the influx of solar energy offers peak potential for electricity production. Atlas might load up its energy storage units, ramp up its magnetic coil systems to full capacity, and unleash a hefty dose of gas ready for ionization. Those magnetic forces would squeeze and propel the plasma, forming a pinpointed ray hotter than the sun's outer layers. Aimed our way, this kind of device wouldn't have to breach the air layers. It could zero in on orbital platforms, info relays, or navigation grids. One blast might knock out scores of spacecraft, shattering our reliance on orbital tech that underpins daily life. Plus, since the plasma fades fast post-release, piecing together the evidence would be tricky. We could chalk it up to a freak cosmic event rather than intent. The push toward plasma barrier advancements, not just in China, but likely in the U.S. and elsewhere keeping their efforts under wraps, highlights a key shift. We're stepping into a time when outer space turns into a battlefield, where covert ops and digital skirmishes stretch past our planet's borders, and the line between non-military and armed orbital resources fades. Against that backdrop, something like Atlas serves as a proving ground. How do we shield ourselves from the unknown? How can we confirm what it is without riling it up if it's touchy? How do we align global efforts amid rivalries over tech edges? These aren't just theoretical puzzles. They're real-time challenges that space outfits and defense forces are wrestling with in secret sessions as we speak. Meanwhile, they hash it out. Atlas presses on, inching toward its solar rendezvous and whatever agenda it's set for. Yet secrets, like restricted sightings and buried intel, can't stay buried forever, thanks to tech advancing to spot what eyes miss. And that's where our tale veers into its oddest chapter so far. Part 15. The tireless AI Skywatcher. Nestled in Chile's Atacama Desert at 2,600 meters high, where the atmosphere thins out and the night skies rank among the planet's sharpest, a fresh type of viewing station went live in July 2025. It skips the flashy moniker, no Hubble knockoff or Grand James Webb equivalent. Known simply as the Autonomous Transient Detection Array, or ATA, it marks a radical change in cosmic surveillance. ATA features 40 modest scopes, each boasting a 40 centimeters lens, laid out in a spread spanning multiple acres. On their own, these units wouldn't wow an expert stargazer. Together, though, linked via fiber lines to a core AI hub, they create a game changer. A facility that runs solo, round the clock without a single human touch, picking spots on its own, snapping shots, crunching numbers instantly, and highlighting oddities for deeper checks. The AI core powering ATA drew from years of sky data, getting schooled on spotting constellations, island universes, exploding stars, flickering lights, space rocks, all the usual suspects. Its mission? To flag weird, fleeting occurrences that buck established patterns. A light that flares or fades without warning. Something zipping along an offbeat path. A light fingerprint clashing with database entries. Spotting a glitch, ATA skips the delay for human sign-off weeks out. It swiftly pivots several scopes toward the oddity, grabbing extra views in varied light bands and compiling a timeline of info in moments. If the weirdness lingers, ATA ramps it up, pinging fellow observatories for backup, views, and more data. Compiling a detailed analysis. The whole sequence, from first spotting to organized pursuit, unfolds quicker than any system run by people could handle. This AI stays alert around the clock, free from fatigue, diversions, or delays for group decisions on adjusting watch plans. In its initial 3 months running, ATA spotted 17 fleeting occurrences missed by prior scans. Many proved to be familiar occurrences viewed from odd perspectives or at unforeseen moments. Yet 3 stayed puzzling, items or incidents that current star models failed to account for properly. One involved a sudden surge in brightness from a star already listed in catalogs. The glow ramped up by 50 times in merely 6 hours, then dropped to normal levels across 2 days. No established star fluctuation process yields that kind of brightness profile. It ruled out a supernova. No signs in the spectrum of atomic blending. It wasn't a pair of stars eclipsing each other. The schedule and balance didn't fit. It simply flared up, dulled down, and went back to routine, leaving experts baffled. The AI marked it as unusual, stored the records, and keeps watching that star, hoping for a repeat. The next mystery was a body cruising the asteroid region with a jagged path, featuring minor speed shifts unexplained by pulls from identified masses. The AI followed it over multiple evenings, figured its route defied standard orbits shaped solely by solar gravity. Some force was nudging it. Perhaps a hidden rock crossed paths at the perfect instant, statistically improbable in cosmic terms, or the thing was steering itself. ATA tagged it for expert scrutiny. But when stargazers checked the info and called for more looks, the body had slipped into a sky patch blocked by the Milky Way's dense disk, vanishing amid the stellar haze. It hasn't shown up again. The third case remains in active study. A spectral signature popped up in a far-off galaxy, mismatched to any recognized atom or compound. It might stem from equipment flaws, a hiccup in the spectrum tool. However, the mark showed up reliably in various shots from arrayed scopes, reducing the odds of a glitch. If genuine, it signals either a fresh atomic shift unseen till now or output from an entity absent from our element chart. Consider what this signifies. It's automated smarts sweeping the heavens, sifting routine from remarkable, running non-stop beyond the prejudices, expectations, or constraints of flesh and blood sky watchers. And now the eerie angle. Imagine if entities like Atlas, if scouts from alien minds, if their traces and actions were crafted for machine detection, not ours? What if a superior society's outreach strategy banks on other tech-savvy beings eventually crafting AI sentinels, ones that pick up cues organic brains overlook? We seek what fits our grasp: suns, worlds, icy wanderers, vast star clusters. Our spotting skills are shaped by natural selection and societal lenses. But in AI-fed raw data, unburdened by notions of the plausible or impossible, could uncover what we ignore. ATDA's catch of the off-orbit rock ties directly to Atlas. Picture more such subtle craft lurking, dimmer, stealthier in their adjustments. Traditional observers might dismiss them, chalking path quirks to vapor ejections, the Yarkovsky push, or measurement slips. Yet an AI tuned to spot non-Keplerian paths would nab them right away. ATDA could already be uncovering a fleet of man-made solar system intruders, labeling them oddities, though those alerts languish in storage pending our slow checks. And we're the jam. The AI spots and logs, then idles as we argue, assemble panels, chase funding, draft plans. All the while, those visitors press on, unchecked by our plodding pace. This raises a profound, troubling query. Suppose the cosmos has been reaching out to us for years, ages even, beaming messages, launching envoys, dropping clues, but we've missed it, scanning through mortal sight and ingrained ideas. At last, we've forged synthetic vision and AI tools that perceive anew, that detect motifs beyond us. And these tools are beginning to register what's always been present. ATDA marks the start. More AI-powered scopes are in build or design phases. Learning algorithms weave into current ground scopes, orbital platforms, radio networks. In 10 years, nearly all sky surveys will flow through AI filters, with people in supporting roles. Supervisors and interpreters take the place of primary watchers in this shift, and through it, we could uncover that the universe is infinitely weirder and more crowded than anyone ever dreamed. Not due to any alteration in the cosmos itself, but simply because we've at last figured out how to observe it correctly. The story aligns awkwardly but fittingly with Atlas. Its oddities, the abrupt surge in hydrogen cyanide, the backward tail, the unpredictable luminosity, are precisely the sorts of signals that an AI monitor would highlight. A human stargazer could brush them off as typical comet oddities, yet an AI programmed to spot breaks from standard patterns would label Atlas as exceptionally irregular, calling for thorough investigation. And supposing it had been active during Atlas's distant, inactive, and dim phase, might the AI have spotted it sooner? Could it have marked Atlas as dubious prior to the outburst, drawing on faint path irregularities or spectral clues that escape human scrutiny? We'll never find out, since ATDA launched after Atlas had already gained notoriety. But objects resembling Atlas in the future won't evade notice so easily. The AI will keep vigil, adapting, honing its spotting methods from lessons drawn here. That signals the close of the period when covert artifacts or bodies glide past our solar system undetected. We're stepping into a time of AI-driven openness, where synthetic sentinels scrutinize all, sort everything, and allow few enigmas to linger unresolved. Yet openness has a double edge. If AI telescopes pick up engineered entities, who holds the reins on that knowledge? ATDA draws funding from a mix of academic institutions and state bodies. Its findings are in theory accessible to everyone, though protocols exist to hold back revelations for expert vetting, security assessments, or global alignment. Should ATDA uncover something truly startling, like proof that Atlas is man-made or signs of more intruders, would that intel go straight to the masses or end up sealed, funneled to spy networks, and disclosed only once officials deem society prepared? The AI won't choose, people will. And as history shows with Psyche's blackout and ES info holdups, people often clamp down on details when fear grips them over public backlash. So now, in October 2025, we track Atlas nearing its closest solar pass. Aware that machine networks probe the heavens with senses sharper than ours, that officials and cosmic organizations hoard unshared details. Aware that energy fusion ventures crumble as unseen black holes wander the stars and lab-born quantum time crystals turn from theory to fact. The backdrop has grown beyond mere stargazing. It spans tech, governance, and our very being. Atlas stands at the center, weaving these strands into one compelling tale. And that tale races toward an end we can't glimpse yet, but sense building like a far-off tempest. The issue isn't if Atlas is engineered. It's what unfolds when denial crumbles. What occurs as machine watchers amass irrefutable proof, as irregularities stack so tall that even die-hard doubters must concede the standard story falls short. What transpires as Atlas hits perihelion in late November? As sunlight surges, as its intended purpose turns impossible to ignore. Are we prepared? Do states have guidelines for this? Or do we scramble on the fly, crossing fingers, handling a cosmic peril like mere red tape sortable via panels and announcements? I lack responses to these puzzles. No one has them. We're charting unknown waters, guided by gut and partial facts, eyeing an entity that could rank as humanity's greatest find, or merely in quirky iceball mimicking every trait of a crafted scout. The vagueness torments, the doubt feels intentional, and the quiet from powers that be, the opacity, the measured drip of news implies they're just as bewildered and scared as the rest. Yet they stick to the act of mastery, upholding the facade that they grasp the situation and hold the reins firm. But one truth stands clear to me. The cosmos ignores our pretenses. Atlas exists. Its path is predictable. Its outputs quantifiable. Its actions trackable. And no matter its nature or intent, revelation looms near. Perihelion draws within weeks. The hydrogen cyanide haze keeps swelling. The AI stations persist in their gaze. And in secured strategy hubs and crisis huddles, those privy to hidden records shape choices impacting every soul. Choices on reaction, on alerting the world, on stepping in. Or simply hold out and wait. We unveiled the veil over Atlas, spotlighted the irregularities, linked the pieces together, and posed the inquiries that demanded answers. Yet the universe offers no easy do-over. Once you've witnessed the unveiling, there's no erasing it from your mind. You can't feign that all is ordinary after catching sight of the underlying design. So keep your gaze on the heavens, not merely through sight alone, but with the knowledge that appearances may deceive, hiding the true reality. Stay alert for instances when established stories alter course, when doubters abruptly turn converts, or when information meant for all eyes gets locked away with no rationale. Be on the lookout for indicators that events are unfolding in the shadows. Measures being taken for possibilities they refuse to address openly. Observe Atlas on its path closer to us. As it glows brighter or stays dim, acts as expected or defies norms, emerges as the celestial visitor we anticipated, or discloses itself as the enigma we dreaded. Bear in mind that the cosmos stretches endlessly, carries the weight of eons, and brims with mysteries beyond our grasp. Atlas could mark the start, the initial discovery enabled by our evolving tools to pick up on such oddities. What other entities lurk out there, inactive, poised, observing? For how many ages have they lingered among us? And what unfolds when they stir to life? These riddles haunt my sleepless hours, lying there gazing upward, pondering whether dawn brings the shift that alters it all. The proof lies before us. The sequence of events is unmistakable, the danger is tangible, and the hush from those most informed echoes as the sharpest alert.